Cool. There we go. All right. Hey, hello. Okay, cool. Good morning, everyone. I think we should get started. I hope you're having a good time so far here at the event. Probably this talk, it's a little bit low level. There's going to be a lot of code. And yeah, so if you get bored, just raise your hand and we switch topics or whatever. Yeah, cool. So, this talk is called What Mom Never Told You About Multithreading. Just a quick introduction. My name is Fernando Cejas. I'm not going to say much about it, just like that I'm here to share all the disasters I made as a professional in my career. It's always nice to learn out of mistakes and so forth, right? I come from Argentina, so this country here, I'm currently living in Germany. We still don't have representation in Street Fighter, so something we're dealing with. And I always like to tell why this talk. It's not the first time I'm giving it, so I've been evolving it and collecting some feedback, and I hope that you guys provide me with some feedback afterwards, constructive one. So, why threading? Why this talk? So I remember myself like 1 year ago. This is my mom and sister. Yeah, we were grabbing a beer, and we were sitting down in a bar and I was curious and said, "Mom, what is multithreading?" It's like, but it's true actually. I was doing like this kind of social experiment and say like, okay, let's ask my mom, what does she think about it? What does multithreading means for her? And she said, "Oh my God, my little son, you're not prepared for that yet." And she mentioned like, okay, may the force of multithreading be with you, right? And that was not true, but she was like, "What the hell are you talking about? What is this multithreading thing? Why you brought up to the table here? We're just getting drunk, grabbing a beer, like as a good family, doing it together." So then is when everything started. So for some reason that came to my mind and said, okay, I'm going to investigate a little bit more about multithreading, because sometimes we do things in a multithreaded environment and without knowing what's really going on, right? And most of the time we follow up our heart and search on the internet, or we do Stack Overflow driven development, right? But we don't know what's going on under the hood. So one of the things, let's read together actually some quotes that I collected from the internet when we talk about multithreading. People always say like multithreading is hard, which could be true, but we'll see that it could simplify some stuff too. Yeah, redesigning your application to run multithreading on multi-core machines is a little like learning to swim by jumping into the deep end. Those are not, statements which, are, very encouraging. Like it's just like, yeah, that must be super tough. Or, yeah, there's another thing. Like the wall is there. We probably won't have any more products without multi-core processors, but we see a lot of problems with parallel programming. And that's in part true. We're getting more and more devices, more powerful devices. And I think most of the time we are not taking advantage of all the capabilities these devices bring us up. So another thing, usually when I investigate some topic, I like to relate that with the nature. What happens, with a human? We as a human beings, We're not multitasking. I will give you some insights on this. The thing is, we can do a couple of things in parallel, like, for example, I'm just walking, moving a little bit here, and talking. And that's managed by the frontal part of the brain, and that's called autopilot. I mean, we can do these tiny things at the same time without so much effort, right? But what happens when we want to do something more complicated? I mean, we're not doing it at the same time, but the brain, the frontal part, has like a queue of tasks. Let's look at it this way. And it's constantly switching context, super fast, very fast. But with that being said, we have to say that computers are multitasking. And we can run many things in parallel, concurrently. So here's the first question. What does parallel mean? What does concurrently means? Do you know if there's any difference? Do you think there's a difference between parallel and concurrent? Or do you think they're the same thing? Because this is important for the concepts that are coming up. Here's the thing. These are two different things. What's concurrent? Concurrent, it's about dealing with a lot of things, different things, right? And that's what happens with mobile devices. We're dealing with a lot of things, like, I don't know, click events, notifications, many other things that are coming all together, and we have to deal with them in a parallel way. So that's the difference. It's important to have this clear. Like, for example, if we were to write letters here, if we were to write the same letter, all of us here, we were not being concurrent. We're doing it in parallel because we're doing only one thing, which is writing a letter, right? But it's not concurrent because it's only one thing. There's not a lot of things. So keep this in mind in order to understand the concept that I'll be explaining later. Cool. So, yeah, another thing. This talk is not going to be Android related. I'll tell you why. It's going to be about multithreading and trying to understand the main building blocks using different technologies. So that could apply to any, I would say, to any software engineering project. I don't want to talk about, for all of you who are familiar with Android development, I don't want to talk about asyntasks. And if there's someone or anyone in this room who is using asyntasks, just please, you can leave the room. No, it's yeah. I mean, I have my thoughts on this. I think we all agree that it was a good thing in the beginning when everything started, but no longer. It brings up a lot of coupling and so forth. But it's not part of our. It's out of scope of this talk. No handlers, not job scheduler. And the reason. The reason why is because for me it's important to understand the building blocks, what's going on. Everything is going to end up in threads, no matter whatever abstraction layer you're using. But in order to get started with code and so forth, we're going to review a couple of concepts that we need to know about multithreading, and when we are dealing with several things at the same time. So a process, we know what a process is. Let's keep it simple. It's an instance of an application. Let's keep it that way. A thread is the smallest amount of computing instructions that can be executed or handled by a scheduler. Then we are going to be seeing what a scheduler is. It's an operating system feature. Well, let's keep it this way. The scheduler is an operating system feature which is going to handle all the threads and within the processor. But it's managed by the operating system. That's something we need to keep in mind. And there is a bunch of situations which could happen when we are dealing with multithreading. So these things are, I'm pretty sure that many of you are familiar with them. So a deadlock, race conditions, and a starvation. A deadlock, just quickly, is a situation where, let's say, 2 threads are blocked forever. So none of them is making progress. They're going to be blocked, and that's it. That could happen. We will see some situations where that is very likely to happen. A race condition means, well, describes a situation where 2 threads are racing for resource. Let's say there's a common resource which is accessed by 2 threads. And since this scheduler, you remember that I mentioned the scheduler is part of the operating system. So there is an algorithm that the operating system use in order to handle threads, right? And you cannot be sure that, I mean, at any time, the operating system can say, like, oh, I'm going to be switching between threads, right? And I'm going to handle it this way. And not the operating system as only, but like, for example, if you're working with the JVM, then many times we have seen issues depending on the JVM implementation because of that, because of the way these algorithms for scheduling threads work. So it's important here. That's why we need to keep in mind race conditions, and we need to avoid them, actually. In conclusion, 1 resource in common, 2 threads trying to access the resource, and racing for that. That's another situation. Starvation, in simple words, it's kind of similar. Yeah, but the thing is, 1 thread is retaining this shared resource for a long time, and the other thread cannot make progress. It's slowing down other threads which want to access that resource, right? So it's basically about slowing down and threads not being able to make progress. Cool. This is the only Android-specific things that I want to mention here. But it's pretty much the same on iOS, right? I mean, we start an application, we have a process, and everything runs in the UI thread. And the same applies to both platforms. We want to get out of the UI thread. That's something that we know and we should always keep in mind. So that's another question. Why multithreading? Most of the time, we think, okay, it's about performance. Yes, but there's 3 main purposes. We need to know the fundamentals, but why we're doing multithreading? Because we want responsiveness. We can make our applications more responsive by taking advantage of multithreading and doing things in parallel. Resources. Again, as we said before, nowadays we have a lot of power in our devices, and we want to take advantage of that. We want to be able to use all the resources that are available for us within the device, right? So that's a good thing, because that brings up more performance and so forth. And simplicity. This is something that I added here, but yeah, many people might argue and say that when you use multithreading or when you're dealing with threads and so forth, that could bring up more complexity. It's true, at some point. But then you can say that by using a divide and conquer approach, by just making or splitting up your big problem into smaller ones, that could bring up simplicity. So this is a very opinionated. I would say it depends on the use case. Always it depends on the use case. So let's get started with the problem then. We're going to start seeing code here. And I want you to understand what our problem is like. So basically, I'm executing this on Android, but I'm curious about the same thing on iOS again. This could work in both platforms, not at a code level, but like the overall solution It's pretty simple to implement in both devices. So we're going to start solving a problem in different ways using multithreading. So here's the thing. Remember this. So we're going to get Wikipedia pages. If you go to Wikipedia, you can grab XML files with all the information, with all the pages. I mean, they have tons of gigabytes of information there that is free to collect, right? So I just grab a couple of files which contain Wikipedia pages. So here's the thing. It's a simple problem. We get some Wikipedia pages. There's 2 XML files. And I will tell you why 2. Because we're going to be splitting our problem into smaller problems. We're going to loop through every single page in these 2 files, and we're going to count the words for all these pages. Keep that in mind, because it's important to understand then the code. I'm going to be, going back and forth between the exercise and just to make you remember what our problem is. So cool. And all the code is on GitHub. You can play around it. You can, I don't know, provide feedback, improve it, whatever you feel like. So get Wikipedia pages, 2 XML files, each one of 30 megabytes. Cool? I mean, you might not do this in a real, case scenario, right? But this is actually to demonstrate, the problem-solving process. Cool. So let's get started. But in my defense, I always say, first make your code work, then make it right, and then make it fast if it's not fast enough. Here, there's 2 things. Make it right. Here is for learning purpose. So, I could have refactored it, but let's keep it simple. The fast thing, I always say, please don't take care of performance unless that's critical for your business. And I always have this discussion with Martin. Is somewhere. Okay. Oh, there you are. Okay. Because you're the ones and zero, the binary guy for me. So you always go super deep into the details. And we always have this discussion around whether or not to fine-tune performance and so forth. We can continue that with a beer. But for the purpose of this talk, let's keep it simple. So we're going to solve our problems using different approaches. The first one, threads and logs. These are the fundamental building blocks for any multi-threaded framework, whatever. There's tons of abstractions that make our life easier. And if you ask me, I would not say go this way. But why I'm doing it this way? Because it's important to understand the fundamentals. The more you know about the details, the more tools you get for your tool set, right? And it's important, and then we will see, after, everything is going to drill down into threads and logs. Whatever technology you're using, whatever library you're using for multi-threading, then they're going to, at the end, they're going to be using threads and logs. So let's solve our problem. Let's see some code here. Cool. So what I did first is okay, I'm going to parse these 2 XML files, remember, with Wikipedia pages. I'm going to loop through all the pages and count the words and put it in a map. Super simple here. It's Kotlin code. The reason why I picked Kotlin, it's because I'm familiar with the language, and on the side of Swift, it's pretty similar. So it could be understood by iOS and Android developers. Cool. So here what I'm doing, I have my hash map, a normal hash map where I'll be saving all the counts, key value. What I'm doing here, Kotlin has this nice measure time millis function, which takes a block of code as a parameter, and it counts. So it's super nice for measuring. And here's pretty simple. Please don't pay attention to all the details. I'm going to go through them like super fast, and then we can discuss a little bit further. So what I'm doing here is like with only one thread, I'm solving my problem. So I just create a thread here. I get, this is the part where I parse the first XML file, and this is the second one. So what I'm doing is like go to each page, get all the words, and for each word, just count it. And I'm going here and put it in a hash map. Super simple. Let's see the results about this piece of code, how much time it took. So for all that, for getting almost 200,000 words and 2 XML files processes of 30 megabytes each, it took almost 22 seconds. Can we do better? Of course. Let's go for the next one. So I said, okay, I'm going to add another thread here. Because I have 2 XML files, why not? Do you think, I mean, I'm pretty much doing the same, but creating 2 threads and doing these 2 things separately. And by the way, I started using a concurrent hash map. So since I'm using a synchronized collection, it was just as easy as just replacing my hash map for a concurrent hash map. That could bring up some issues, and we'll see later. But do you think this got way better? I mean, if I'm solving the problem with only one thread, what happens if I add another thread? I mean, should be half of the time or not? What do you think? Half of the time? Okay, let's see. Cool. But I run into some issues with this code here. Sometimes another thing to keep in mind is that when we're dealing with multithreading and we think that changing our code is as easy as changing the concurrent hash map and that's going to do all the magic, that's not true. Because here, then I realized that this method here, contains key, is not atomic, which means that happens in several cycles of processor, which means that at some point, when I'm checking for the contains key, in the middle, someone could go there and change some value, and then I would have a race condition, right? So it's important to get to know the language, because then we might run into issues like this one, and then we have no idea where is that coming from. So what I said, like I started having some issues, and like not even, I mean, the word count numbers were totally different. I said, like, why is that? And it took me some time to figure that out. So then I dived deeper into Kotlin and say, okay, cool. So what can I have in order to solve this problem? And there is actually an atomic method for doing that, which is basically the merge. So you just put the word here, you get an old value, and what I'm saying is like, yeah, just do a +1 to that value. But these are the things that we need to know as well, like as part of our engineering process, like getting to know the language in this sense, right? So, so now this is thread safe. Now this is thread safe. So let's see the results. We said one thread, almost 22 seconds. 2 threads, yeah, 13, 14 seconds? No. By adding the double of power, I didn't get, the half of the time. And why is that? So I started to think about that, and why is that happening? But before that, then I said, okay, let's try another technology. Let's try another thing, another framework. In this case, RXJava. It could be the reactive weight, let's say. And I said, okay, something to say about RXJava, and this is probably out of scope of this talk, but don't use RXJava because of the multithreading part. It is way more than that, and many people came up to me and asked me, okay, I'm using RXJava because of that, and it's not because of that, because you might add a lot of overhead for other things, right? I mean, basically use RXJava if you need to compose streams of data coming from different sources. Then you can play around operator. I don't know if you're familiar with RXJava, I guess, or any reactive framework. But I always use the best tool for the job. But in this case, I wanted to try that out. And the way you add multithreading to RxJava is through schedulers. We talk about schedulers. They're a little bit different in RxJava. They are called schedulers, but they're operators. So you can say, okay, an observable, it's a monad. It's a mathematical concept. It's a model. It encapsulates a computation, right? You put some computation inside an observable, and you can play around that and merge stuff. And observables are going to emit items. But and the way you introduce multithreading is through these schedulers. And here you say, okay, I want this computation, which is inside an observable, to be executed in this scheduler. And then you had to go to the documentation and see all the possibilities you have in this sense. Cool. So I started solving my problem again. 2 files, XML files. Go into each Wikipedia page, count the words. And that's with only one thread again. So I created an observable. Again, a computation. You need to encapsulate your computation into an observable. I did exactly the same with my hash map. I don't need here a concurrent hash map. That's for sure, because there's only one thread. It's thread safe. And this is a way you do multithreading with RxJava. Here, the scheduler single, if you go to the documentation, it will tell you that it only executed and emit items using only one thread. And the same thing. And here I can use contains key. The reason why I'm not using the merge is because when you're synchronizing stuff, you're wasting more resources. Most of the time, you're blocking stuff, right? I don't need it here. So everything was fine. Let's see the results. 21 seconds. 1 second faster than our threads and logs. Then I said, okay, let's do RxJava with 2 threads. Same thing, 2 observables here. Yeah, let's count the words. Here I need to, again, choose a concurrent hash map. And I started counting. Results, 17 seconds. And then it's when I started thinking, why is this happening? Why RxJava is being faster? Because then I started diving into the source code of RxJava. And they are using threads and logs in the end. Everything is going to use threads and logs. And then it turns out the reason why that is faster is because it's doing some caching inside. If you go to the scheduler's source code, you will see that it's doing some magic by caching some items and I don't know, doing some magic around the scheduling part and so forth. But it was curious to see that. Then it said, okay, coroutines. Coroutines, of course, those are like, it's basically a language feature, and it exists not only in Kotlin, but in other languages as well. So it's not anything new. What are coroutines in the end? So coroutines are lightweight threads. That means that creating a thread is usually expensive, and we cannot create like thousands of threads. We're going to kill our device if we do that. Coroutines they're not mapping one-to-one to a thread, which means that I can execute asynchronous code in a synchronous way using coroutines, and a thread could execute several coroutines. So that's the main difference, just understanding as that. Then there is a lot of magic. I mean, the good thing about this is like you basically write synchronous code, which is going to be executed asynchronously, which is super good. I don't know if that exists in Swift. I haven't checked that out. No? Coroutines. Exists in other languages. Yeah. Okay, cool. Good to know. So there's a lot of magic then. You know, this is a language feature, and the way it works, as far as I know, there is a state machine. So basically, just to give you some insights, it's like a coroutine is a task that could be started, paused, and resumed. So within a thread. So there is a compilation magic here, and what it does, Kotlin, under the hood, is like with the compiler, it creates a state machine, and it's gonna reuse threads to execute several coroutines. So it's gonna be pausing, executing stuff within the state machine. There is a lot of magic there, but just like to wake up your curiosity if you wanna go deeper and understand that. But the thing is, okay, that's a language feature, and I wanna use it and see the results. So with one coroutine here, it's pretty simple the way you write code. So you basically launch a coroutine here, and you pass in a context. There is a built-in context. In this case, Kotlin provides a new single thread context, again, one thread. And I'm doing my job here. Again, the same thing. The other thing is like you had to declare the method who's going to be asynchronous with the word suspend, because that means a suspend function, which means that it could be suspended, you know, not blocking the thread, but suspended, executing something else, getting back, resuming, and so forth. And that's you know, Kotlin magic used by the at compilation time. Yeah, so let's see. So I'm doing everything in one coroutine, same code, results, almost 21 seconds. And I was like, holy crap. It's like, I've been spending a lot of time here and investigating and see why. Why is that? I did the same with two coroutines here. Same, executing both at the same time with the await, split up my problem into smaller ones and see what happened. 19 seconds. Again, all is the same result, just out of curiosity. So here are the first round of results. I don't know, for some reason the fonts are not working. And then I'm seeing clearly that RXJava did the best. But the thing is, I started thinking about that. What are the problems with all this? And I got some hypotheses. And I knew that we can do better with this solution, and I started thinking, okay, let's try to think about different approaches that we can take in order to solve this problem in a better way. So maybe I can use a producer-consumer pattern. I don't know, that's a very typical, with a queue of tasks, you know, producers putting tasks there and consumers grabbing those tasks and executing them and then returning the results. Then maybe divide and conquer in a better way, like, I don't know, splitting up my problem into very, very small problems. So it's about granularity, right? Maybe reusing threads. Maybe, I don't know, I'm not doing a good job about that. And what about other synchronized collections? I know that at a language level, we have different synchronized collections. And then I said, maybe the bottleneck is over there. And some advice. Oh, God, the font for some reason. So here is like, always analyze your problem, as I did. Verify assumptions. No, please don't refactor code saying, okay, I think I can do better here. But first, measure, because you don't know. We think sometimes that we're getting better, but without measuring. And so my advice, like measure, 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 and measure. And so that's the first step I did here. So I said, okay, I'm going to go and check the concurrent collections where I'm saving my data. Because then I said, okay, cool. So maybe the hash map, the concurrent hash map, is way worse because it's locking the entire map, and then other threads are trying to access there, provoking starvation. I don't know. And that's what I did. I did a test with all the possible concurrent collections. And I ran this test by just inserting 500,000 elements into a hash table, which is another synchronized collection, and a synchronized map, which is a wrapper for any other map that you can use in order to lock it when two threads are trying to access it, and a concurrent hash map. And it was really fast. I mean, look at the difference. This is much faster. So I'm basically using the right collection for this job. So that was not then. Then other things I thought is like, why it's so slow? Maybe it's the input-output? That could be a good argument. Because input-output is always very expensive, slow, and then I thought, maybe my threads are idle while all the input-output happens while reading from this, because remember that there's 2 XML files. And then I said, okay, I'm going to test that out. This is the part when I'm parsing the XML files. I'm just creating this page and going through all the nodes in these XML files and see the test then. And then I said, okay, the creation of the page in memory, it only took 15 milliseconds, nothing. The parsing took like 4 seconds here on the first file, and yeah, 4 seconds as well. So we can clearly see that there is a bottleneck here. It has to do with the input-output, reading from disk. So a lot of things came to my mind then, like how can I solve this in a better way? And these were the first conclusions. Then I said, threads being idle, locking the map maybe, but I was using actually the right collection. And there's another thing, I mean, and this is something we suffer from, not on iOS, which is a reference counting thing. They're using reference counting. I think it would be nice to try that out on an iOS device and see what happens and how better or worse can perform. So, and someone came up with this idea. I collected some feedback, and someone was playing around my code and said, okay, cool. I'm seeing a lot of garbage collection, which means, you know, we're waking up the garbage collector a lot because of the amount of objects in memory we are creating for that parsing. So we can see there's so many opportunities, or possibilities here, sorry. And again, can we do better? Yes. After all these conclusions, yes. And I started thinking again in different solutions. Then I said, okay, cool. So I'm going to start by splitting up my problem into way smaller problems. And here is like, I use Kotlin coroutines because they were easier to implement. And I said, okay, I'm going to create 4 now with a common pool for using threads. And I'm going to split up. I'm going to go, you know, I'm going to be using ranges for pages. You know, inside a XML file, I'm going to read only half of it. Yeah, and split, you know, split that up. And then let's see the results. Same here. Yeah, it's pretty much the same, but using way more coroutines. And I got better. I got a 30% better from the first solution. So remember, it was almost 22 seconds, and by, you know, making some progress, I came up with 14, which is not that bad. It's still bad for that. You might not wait 14 seconds, right, to an app. This is probably not a real use case scenario, but for the purpose of learning, it was a 30% better. And then I said, okay, cool, let's see the numbers. And then I started thinking about it, and then said, okay, we can do better? Yeah, of course, but that's homework. I mean, I was super tired of like digging into the code and trying to get better at that, so I decided to go for a beer, sorry. So if you want, if you want to do it, like, you can contribute here. I'm always like super open to sit down and do some pairing or whatever with someone, to just dive into the code and understand it and getting better. I'm pretty sure that you will come up with better solutions, because all the things that I thought is like maybe, I don't know, puts everything in memory and see how that performs, improving, I don't know, algorithms, whatever. So, during all this process, and especially when dealing with multithreading, there is a bunch of problems that you might face. Debugging is not easy. Debugging is not easy, especially in multithreading environments. Of course, like, when you have a lot of mutability and global state, you can have like a lot of inconsistency or inconsistent state across your app, and then you don't know what the hell is going on. Testing and sharing state is pretty much the same as mutability. Testing is not straightforward. At the language level, at least on the Kotlin side, you can run, there is a function which is called run blocking, and you can run code inside in a synchronous way. So you want to use that for testing purpose. But the good thing here, the conclusion, is to always understand what's going on. I mean, I learned a lot about threads and logs by just, learning about how Kotlin does it, how RXJava does it. Everything ended up, again, into threads and logs. But when you have to solve a problem, this was more like a problem-solving technique. You go from the worst to the best, not the best in this case, but you improve, step by step. And that's why I consider, getting to know the fundamentals is very important. Just to wrap it up, I would say that always use the right tool for the right job. In this case, again, it has to do with RxJava. I'm seeing a lot of code bases with RxJava or within the reactive way. I remember at SoundCloud, our iOS app was using reactive Cocoa, I think, right? Cocos, it's called, right? And it was completely refactored because it was bringing a lot of overhead, and we didn't actually need it. Always measure. Don't make assumptions. Measure. There's tons of tools out there in order to measure, and then you will be able to refactor it to get better at something. No silver bullets, again. That was my solution. I mean, many people after the talk and gave me some feedback about other ways of solving this problem. So hopefully you will come up with something better. And again, this is, I'm a big defender of this. And make your code always right, and then start gradually improving it in terms of performance. There's a bunch of things that I would definitely love to do. I think we can learn from other technologies. I definitely want to explore memory consumption. That's another thing. Because of the garbage collection activity, I should have profiled that, but I didn't have enough time, and it's not straightforward. But that's something I wanna do. I do want to use Android threading components and see how they perform. If they're better, I mean, and then I will have to shut up. And kudos to the async task. Maybe some external libraries. I know that there is a bunch of libraries which facilitate, of course, solving these kind of problems. I think there is a popular one which was built by Evernote for dealing with threading. I want to try that out. And then, of course, I want to explore more the iOS threading model. I'm not familiar with that. I know that there's pretty much only one way to do it, like through the Grand Central Dispatch or something like that. And it would be very interesting. Maybe we can kind of bring that up to our platform. And maybe server-side multithreading. I know many people who are trying, I don't know, other approaches, like, let's say, the actor model. It's doing distributed multi-threading through message passing. There's a bunch of things that we can use. There's other types of collections in Haskell which allow you. They can be accessed by tons of threads at the same time, but being still thread safe. And yeah, again, other solutions could be interesting to explore. And again, always, yeah, we want to bring multi-threading because of these three things. That's the main purpose of that: responsiveness, resources, and simplicity. Simplicity could be a point of discussion here, but yeah, of course we can talk about it later. I think that's pretty much what I have to offer in regards to this talk. I hope you found it useful. I don't know if we still have a couple of minutes for a couple of questions. All the while, I'll stick around today and tomorrow, and I'm happy to talk to all of you about anything. And I think there is a space right outside, so I'm going to be there in the last half an hour, I think. You can find me here. This is my Twitter. As you can see, I don't know why the font is looking good. It works on my computer, but I have my blog, and this is my GitHub account. So yeah, I think that's pretty much. Thank you very much. Are there any questions or yeah?
Hello.
Hello.
I admire your job, by the way. And,
thank you.
Yeah, a very good presentation. And I'm not so familiar with Android system, but I would like to ask if you know, is there a way to do concurrent programming on Android? I mean, on the multiple cores and so on, not the multi-threading.
You mean taking advantage of the multi-core stuff?
Yeah.
I think, I mean, you should be able to do it like this way, actually. I mean, I haven't checked that out, which core it's being used, but that could be a good thing to do, actually.
Okay, so you think that schedulers does this job for you?
Yeah, exactly. Okay. So I think there's been, I don't know, in the past, depending on the Android version, there were some issues with the schedulers, behaving differently. Depending on the version, but I think with the latest versions, they got better. But it's something that I definitely love to explore. Yeah.
Thanks.
Yeah, thank you. Another question here?
Hi.
Hello.
Actually, when the last guy brought up multi-core,
yep.
I was thinking if we could take advantage of the GPU and its core, so in case of multi-threading.
Yeah, as far as I mean, that could be a good catch, actually. I don't think so far. Maybe someone could shed some light on this, but I don't think we can take advantage, not yet. But I think it was a topic of discussion. Like when I was actually investigating that and all the possibilities, someone came up with the same idea and say, hey, why don't we use this powerful processor that we have for drawing the UI? And I don't think so, but I'm not sure, so I cannot tell.
There is one way. Sorry, I'm
okay, cool.
There is one way you could
okay, cool. Yeah.
make use of the GPU, and that's using RenderScript.
Oh.
You could run a RenderScript kernel on the GPU.
Okay, thanks. Thank you, yeah. That's good to know. Maybe that's something I could apply here too. Cool, thanks. Yep. Okay, cool. Then see you outside or around. I'll be here, today and tomorrow. And please hit me up and show up, and we can talk about anything. Cool. Thank you very much.